here we go, guys. I pulled up a Khan Academy lesson, and I did it specifically because Khan Academy is great. They give you lots of notes. I mean, you can learn all the way through Calc 3 and all kinds of science on your own through Khan Academy. I mean, actually, it doesn't feel like most of you can, but if you start to like pay attention to how I go through this, you probably will be able to like, honestly, without that much difficulty, guys. Stop thinking being smart is something you inherit. You're just born with. It's not. Guys, smart people just have little tricks. They just have little hacks. And I'm trying to show you, a lot of people think I'm smart for passing this math test. I'm not smart. I'm smart, but I use specific strategies, and you can use the same strategies. Oh, and then lo and behold, what's that make you? That makes you smart. So the first thing I noticed on this FAIT-P idea, FAIT-P, F, focus on the objectives. So what's cool about Khan Academy is they're right here. I need to learn what the image of a transformation is. Okay, I don't even know what a transformation is. Transformation, what the rigid transformations and which transformations are not rigid. Okay, so listen, that's a lot of objectives. I'm going to focus on the most basic one as I look at this. I'll look at those another time. But right now, the most basic part is just I need to know what transformations are. So I'm going to watch this video and notice this is one of the few times I will actually just like listen. Is at the very beginning, because at the beginning they usually set the stage. So let's let Khan set the stage.
The word in everyday language, transformation, means something is changing. It's transforming from one thing to another.
Yeah, like Transformers. I would have been predicting this before, like transformation. I see that transform in there. Maybe we're changing something. Now I'm looking at this picture, like what could be changed? I see this blue shape. What could we change about the shape? We could change the number of sides. Wait, if I change the number of sides, it's not the same kind of shape. I could change how big it is. I could change like where it is on the graph. Um, I could like change its orientation. Right now, it's kind of pointing down. I can make it point different ways. I'm making predictions, guys. It's that fate P. I'm making predictions. All right, transformation.
So what would transformation mean in a mathematical context? Well, it could mean that you're taking something mathematical and you're changing it into something else mathematical, and that's exactly what it is.
It's changing something mathematical into something else mathematical. I think I got it, but I this problem, I'm not sure how that helps with this problem.
Talking about taking a set of coordinates or a set of points and then changing them into a different
Coordinates. Okay, time for me to inventory. FAIT-P, FAI, inventory. Um, he said coordinate points. Oh, I kind of remember like this T right here is at, I can't remember what came first, 3 or -3, but it's like that parentheses. There's the coordinate pair. I remember seeing this. I think it's -3, comma 3. We'll see. Keep that in mind. But I think I know what he means by changing the points. But if you change the point, you're going to change the shape. Maybe that's what he's talking about. I don't know.
set of coordinates or a different set of points. For example, this right over here, this is a quadrilateral. We've plotted it on the coordinate plane. This is a set of points, not just the 4 points that represent the vertices of the quadrilateral, but all the points along the sides too. There's a bunch of points along this. You could argue there's an infinite, or there are an infinite.
An infinite amount of points. What? Okay. Pacing, guys. I know this is the beginning of the lesson, so I am sitting in it. But pacing means like, do I need to speed up? Do I need to back up? Do I need to pause? I get the idea that there's 4 points here, but what does he mean infinite points? Let me back up a little bit, see if I can get any insight into that.
A bunch of points along this. You could argue there's an infinite, or there are an infinite number of points along this quadrilateral. This right over here, the point x equals 0, y equals -4. This is a point on the quadrilateral.
Oh, 0, 4 would be this point where the blue line is. So I guess he's saying the line is made up of an infinite amount of points. That makes sense. Like point, 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 point. Okay, I got it. Did you guys see how I inventoried? See how I asked questions? See how I paced?
Now, we can apply a transformation to this, and the first one I'm going to show you is a translation, which just means moving all the points in the same direction and the same amount in that same direction. And I'm using
I lost attention. He said they're going to move all the points in the same direction. Oh, translation. That's what a translation is. Okay, we're learning how transformations are. He's going to basically move all these points somewhere else on the line, and that's called a translation. Listen to me, inventory. I didn't understand that until I started speaking it. All right? You've got, look, we're a minute into this video, and look how much I'm stopping and asking. Now, that doesn't mean this is actually going to be way faster than just watching a video, guys. It's just, it's slow because I'm vocalizing and pointing to you what I think. But this is actually really fast when you just stop and think.
Using the Khan Academy translation widget to do it. So let's translate. Let's translate this, and I can do it by grabbing onto one of the vertices. And notice I've now shifted it to the right by 2. Every point here, not just the orange.
Okay, so my goal, I remember my goal is what is a transformation? And I think I'm getting it. So far, they're showing me that transformation is taking all the points that make up that shape and moving it. But there's other ways I could transform. Like, couldn't I like shrink it? Couldn't I rotate it? So here is where I'm no longer going to follow. He talks about a widget, whatever. I'll find that. But let me just kind of like zoom through and see what else is going on. Okay, at this point, whoa, look at this here. He shrunk it. So he might say what that means. I don't see in my objectives that I need to look up like what that's called per se. I'll look at it. Let's see. What is that called?
For example, I could do a rotation. So I have another set of points here that's represented by quadrilateral, I guess we could call it CD or BCDE, and I could rotate it. And I would rotate it around a point. So for example, I could rotate it around the point D. So this is what I start with. Let me see if I can do this. I could rotate it actually, let me see. So if I start like this, I could rotate it 90 degrees. So I could rotate it.
Okay, so I get it. All those points are rotating to a new position. So far in my transformations, again, I'm inventorying. So far in my transformations, I've had moving. I think he called it translate. Then we have rotating, right? Now, I'm not going to go back and look if he called it translate. That's fine. I'll get that later. My goal right now is what is a transformation? And so far, it's moving them left, right, up, down, and rotating. Let's see if there's other ones. I thought about shrinking. So I'm just going to you can see, I'm looking at the video previews as I go forward. What's he doing
It's a different rotation. I could rotate around any point.
So he rotated around D earlier and we saw it, but he could also say, hey, this point right here at the origin at 0, 0, he could rotate that way. I mean, I thought that was a movement, but I guess you could call that a rotation too. Interesting.
Another transformation, and that would be the notion of a reflection. And you know what reflection means in everyday life. You kind of imagine the
I know what reflection means in everyday life. It's like a mirror, right? Like a mirror reflection.
Reflection of an image in a mirror. Or
is that what he's looking at? I don't want to hear him talk anymore, so I'm going to fast forward. There's like a little dash, dash, dash line. What is he trying to do here?
Let me make a line like this. I could reflect it across a whole series of lines. Whoops, let me see if I can. So let's reflect it across this. Now, what does it mean to reflect across something? One way I imagine is if we're going to get its mirror image, and you kind of imagine this as kind of the line of symmetry, that the image and the original set of the original shape, they should be mirror images across this line.
Wait, so he said something about line of symmetry or something? I don't know. But this was called something. I guess he's saying it's kind of like a mirror, and he's going to reflect it. So I'm guessing this is going to look like that, but like on this side. So I'm trying to picture it in my head. Let's see if it looks how I pictured it. Oh, yeah, it does. I fast forwarded, guys. I didn't listen at all. Okay, so I had the moving, I had the rotating, and now I had the reflecting. All right. Okay, cool. So I can move forward. Is there anything else that I'm missing? I'm just gonna kind of
thing that you can't kind of stretch or quickly between their corresponding y, the measurement. You can imagine these are kind of acting like rigid objects. You can't stretch them. They're not flexible. They're maintained.
Oh, he's now addressing the rigid idea. I remember that was part of the objective, is rigid transformations, and he's saying they're rigid because there's not. It's kind of like they're like the the shapes themselves are kind of like locked in. There's no like changing them. These are just we're just changing the position. Okay, that makes sense. So that makes sense why I wouldn't do like shrinking or enlarging because that would be a different kind of transformation because that would be like actually changing the skeletal shape. I think let's listen.
maintaining their shape. Now, what would be examples of transformations that are not rigid transformations? Well, you can imagine scaling things up and down. If I were to scale this out where it has maybe the angles are preserved,
See what happens when I make predictions, guys? That's what I thought. That's that's what I thought.
but the lengths aren't preserved. That would not be a rigid transformation. If I were to just stretch one side of it, or if I were to just pull this point while the other points stayed where they are, I'd be kind of distorting it or stretching it. That would not be a rigid transformation.
Okay, I think I got it. There was just basically just keeping the same shape, but moving it around, rotating it, or reflecting it. Okay, those are rigid transformations. I think that's all this video is going to cover. Let me just kind of
At
go
performing
forward.
mathematical transformations so
Yeah.
that you can immerse yourself in a 3D.
So guys, that might have taken a while, maybe even longer than the 7 minutes 22 seconds of this video, but probably not. And it's notice how much of the video I did not have to watch. Why? Because I focused on what I needed, the objectives, and what I needed to know. I asked questions. I um, I inventoried what I was learning. Okay, I FAIT-P. T. I sorry, I'm blanking, guys. I tried. I tried it. Remember when I was kind of like scoping or drawing on the thing? I tried it and I made predictions. I made predictions throughout. This is how you learn easily.